Hey everyone, welcome back to the channel. Today I'm super excited because we're diving into something every CIE AS physics student must know, or more precisely needs to know. Basically, it's all the key formulas you need to know for 9702 AS physics paper, whether it's paper 1, 2, 3, not really. Maybe for uncertainty you might need it, but mostly for paper 1 and 2. So whether you're just starting out or you're gearing up for your exam, having a solid grip on these formulas can seriously help you a lot. Because in paper 2, just by writing formulas, of course the right formulas, the correct formulas based on the question, gives you 1 mark. Just imagine there's 10 questions that has or needs you to use formulas, you get 10 free marks. Of course, given that you write the correct equation. Yeah. So I'm not going to go in detail every chapter. I'm just going to touch down because this is just an overview of formula. If you realize that you're not sure what is the formula about, don't worry. Go back, revise a little bit on what the formula means or what is it, the derivation behind that if you need to know. Okay, so without further ado, let's get started. First chapter, physical quantities and units. Oh, what a chapter. Amazing chapter, right? No formulas, but you need to know your base quantities and SI units well, and your prefixes. Make sure you know your prefixes. If you haven't memorized them yet, please memorize it. I suggest you to use acronyms, and I'll share with you what did I use when I was memorizing this. I used the great, man, king, drinks, coal, milk, until 9 PM. This is tera, cause it's T, right? The great is G, giga, mega, kilo, deci, centi, milli. This one is a bit different. I know this is supposed to be micro, but I know you might be thinking, how does micro looks here? So if you see this symbol, right, doesn't this look like a U to you? Right? So that's why it's more of representing the symbol. So this is actually micro. Yeah, because it looks like U, right? So until. Yeah. 9 is nano. PM, P is pico. Okay. Now the value for prefixes times 10 to the power of 12. This one, the first 4 here follows multiples of 3. 6 times 10 to the power of 3. Deci is where you start negative, times 10 to the power of negative 1. Centi is negative 2, times 10 to the power of negative 3 milli. Micro, okay, I'm going to put micro down, sorry, because now in no space. Times 10 to the power of negative 6. Back to multiples of 3. Nano is 10 to the power of negative 9, remember? 9. Pico times 10 to the power of negative 12. Yep. If you already have a set of acronym that you use to memorize, please stick to that. This is just in case you don't have one. Alright? Okay, next one, combining uncertainties. First one, if multiplication or division, you add the percentage uncertainty. If it's addition or subtraction, you add the absolute uncertainty. I'm going to touch a bit on this, give you a simple example. Let's say you're measuring area of a table. Okay? Of course, CIE will not give you that for sure, but give you a simple example for you to understand the concept. Your length is maybe 3, and your absolute uncertainty is maybe 0.03 meter. Then your length times width, so 2. Your width is maybe 0.02 meter, is your absolute uncertainty. So we know area is length times width. This is a multiplication relationship. So in order to find your absolute uncertainty for your area, you need to find the percentage uncertainty of this. How to find your percentage uncertainty? Use this formula. So I give you an example for length. To find the percentage uncertainty, first of all, for your length, 0.03 over 3 times 100%. This is for your length. Then since you need to add the percentage uncertainty, add with your width. Then you get a percentage value. Then to find the absolute uncertainty for your area, take this total percentage times by your area. I'll just do one simple one, okay? Quick one, because since it's a simple number. Oops, sorry. 2 times 100%. If I'm not mistaken, you'll get 2%. If I am not mistaken. You're supposed to get 2%. Yep, 2%. So this is your total percentage uncertainty. You want to find the absolute uncertainty of your area. What you do? First find what is your area. 3 times 2. You get what? 6 meter per square. Absolute uncertainty of area, what you do is 2% times 6. 2% of the area. Because this is your 2% here. You get 0.12 meter square because you're taking percentage of your area. So make sure it's meter square. So your final answer would be area equals to 6 plus minus 0.12 meter square. You add your percentage uncertainty. Okay, simple example. I'm going to erase this because we might not have space. Right, so erase. I think the above one can leave it for a bit. Then the next one is addition or subtraction. So a simple example, let's say you're measuring length or distance. I have two distance. First, perhaps distance is 5 cm plus minus 0.1 cm. That's my absolute uncertainty. Then my second distance may be what? 3 plus minus 0.2 cm. So you want to find the difference between these two distances. So the difference is we take D1 minus D2. Of course, the big minus small lah, distance, right? And this is a subtraction relationship. So if it's a subtraction relationship, how you find the absolute uncertainties for your differences? You add them. So you add this to 0.1 plus 0.2, you get 0.3 cm. Your differences is your minus, you get 2 cm. So straight away, your final answer is difference. I'll just put D equals to 2 plus minus 0.3 cm. Okay. Yep. So subtraction, add. That's it. Simple as that. Okay. Okay, now. Easy, right? Just very little formula you need to know for first chapter. Okay, so first chapter, done. Next, kinematics. Whoa, I believe this whole thing, kinematics until this dynamics, you have seen this question so many times in your life. IGCSE, SPM. Oh, if you've done a lot of practice question, I bet you've been repeating this in your head already. Right? Something you must know. The one that is highlighted in yellow is given in exam. If I'm not mistaken, the second page of your formula sheet. Yeah. This too is not given. But I believe it's already embedded in the neurons already, you know. Yeah. Dynamics, F equals to MA, W equals to MG. The famous formula. In fact, F equals to MA is the name of this YouTube channel, you know. Okay, anyways, jokes aside, moving on. Okay. I specifically wrote here in campaigns for a few reasons. If you are someone who memorizes, and let's say in exam, I hope with God's grace you don't panic. Please do not panic. If you did, stay calm, go to washroom. Breathe in and breathe out. If you can't go to washroom, just breathe in and breathe out. Because if you were to memorize this about inclined planes, you might mix it up. Because in inclined planes, horizontal is mg sine theta, which is w sine theta. Because this is your weight. Right, so horizontal is w sine theta. Not inclined plane, it's f cos theta. It's cos. So if you are someone who memorizes this thing, you're going to mess up an exam sometimes. If you memorize it wrongly. Yeah. So best thing to do, straight away, just derive a very simple triangle. Just draw a triangle here, you have your angle here. This is theta, this must be theta also. Adjacent is cos, so vertical is cos. Horizontal is opposite sine theta. Case closed. Trigonometric function applied, you got it. Less than 30 seconds. This one, draw a fast triangle. Adjacent is cos theta, opposite is sine theta. There you go. But I believe if you do a lot of practices, This one is also already easy for you already. You probably have already, you know, your brain knows what to do during exam. Yeah. Just, my suggestion is don't memorize all this stuff. Make sure you know naturally how to come up with it. In case you suddenly in exam you don't know. In case, you know. But I know that's not going to happen to you. All of you are really smart people. So I believe all of you are going to do really well. Regardless. Okay. Next, force, density and pressure. These two was given in exam, the one highlighted in yellow. So let's start with the first one, density. Very famous also, I believe. Mass over volume. Pressure is force per unit area. And this is pressure of solid. Okay. Third one is hydrostatic pressure. This is just a fancy way of saying pressure in liquids. Yeah, it's just a famous way. And this is rho GH, density of liquid, gravitational acceleration, and your height. Or people call it depth sometimes. Yeah. The last one is upthrust, where is rho GV. This is from Archimedes' principle, where rho is density of fluid. Oh, also bear in mind, only this particular part is given in exam. Yeah? This behind part is not given. I wrote it for you, just for you to know, because sometimes the rho here, see this rho here, right? Some students might wrote rho as the density of object, which is wrong. Make sure rho is density of fluid. Trust me, CIE will purposely give you both density. They will always do that for fun one, and they'll see which one you use. Don't fall into that trap. Please don't, because you're way smarter than that. Density of fluid. Because upthrust sometimes we use to find weight of liquid displaced, etc. So remember, rho is density of fluid. Okay. Right. Other than that, you are good to go. Perfect. Chapter 4, done. Next one. Too bad lah. For this chapter, work, energy, power, too bad. The entire thing is not given to you in exam. Now you somehow have to memorize it. Sorry, my friends. Very sorry. But I think by now you already know these formulas lah, because some of this is quite repetitive from your IG or SPM, right? Work done, force times displacement, nice. Kinetic energy, half mv square. GPE, potential energy, mgh. Power, work done per unit time. And another formula for power is FV. Okay, this might be a little bit new because I don't think you've learned this in IG. Okay, I'm not sure about IG, but I'm very sure SPM don't have. Actually, I don't remember. Okay, anyways, doesn't matter. This one, you can use this formula when the question give you, let's say they say, car is moving with this force and the constant velocity of, let's say, 30 meter per second. Usually it's constant velocity. And if you have that, you can use this power formula equals to FV. Okay, so you have two different power formula to use. Last one, efficiency. Efficiency, you have this formula, useful output energy, or you can either be useful output energy or useful output power. Depending on the question, you can use this formula. Divided by total input energy, or of course power, times 100%. Okay, if they ask in percentage, give in percentage. If let's say they ask ratio, don't ever in physics give in fraction as your ratio. Ratio in physics is always decimals. Because I have a habit of writing ratio in fraction like this. Because when you do maths, right? When you do maths in general, ratio, you are used to writing fractions. Very rare you write 0.5 like this one. Very rare. But in physics, they don't want to see fraction. They want to see this. The reason being, I believe, is to see how well you use your significant figures, I think. Because minimum 2 significant figures, right? Maximum, I think, just go 3 lah. But minimum is 2 significant figures in physics. If, let's say, your final answer is 2 meter. You write like this, it's wrong, because it's not 2 significant figures. You must write 2.0. Even though your answer is correct, it's wrong. Nope, it's wrong. Yeah. So ratio, remember, always decimal. Unless specified otherwise. Read the question carefully. They ask fraction, give you fraction. Usually they don't ask fraction. They just straight away ask you, okay, give the ratio. decimal, always decimal. Yeah, minimum 2 yourself. Because I have the habit of writing fraction. So whenever I start my physics paper, I always tell myself, this physics paper ratio must be in decimals. Okay, alright. Now that's done with chapter 5. Also chapter 6, too bad lah. Luck is not on your side. No formula is given, you have to memorize, you have to know all this. But it's very simple one. Stress is force per unit area. Stress is almost like pressure. It's the same formula, right? Force per unit area. We have strain, which is length after deformed. What do I mean by length after deformed? Sounds very fancy, the word, right? Simple words, final length minus original length, or other words, basically the extension. Then divided by original length. Moving on, Young modulus is stress over strain. Not strain over stress, stress over strain. The way I memorize this is a bit weird. So stress, right, has 3S. So I see like first. So stress first. It somehow goes along, the two words. Stress first. So that's how I remember Young modulus is stress over strain. I know it's weird, but if you already remember this formula, just stick to that. It's just I've remembered it this way because I find it hard to remember Young modulus sometimes. I always mixed it up at times. But then so I started to say, oh, stress first. Okay, so I always put my stress over strain. Yeah. Last one, elastic potential energy. I think this one also quite famous, the formula. As in, you might have seen it before. Half kx square, half fx. Remember, units must always be consistent. If your spring constant is Newton per meter, x must also be in meter. Oops, in meter. Don't suddenly you x in cm. You're going to get a very different answer. Always make sure when you want to perform any calculation or compute any value, check your units. Always check your units. Then check your final answer there. Sometimes Cambridge, right, they have the habit of writing nanometer as your answer. So probably calculate all the way in meter. So make sure you know how to convert from meter to nanometer. Check your unit when you are calculating and check your final answer space blank, what they wrote. Is it a meter or is it other prefixes? That is why it's very important to know this part. If no, you're going to stuck here. So check 2 things in exam. Okay. So, yeah, that's about it for chapter 6. Then next one, waves. So waves, here first one, V equals to F lambda. It's quite familiar as well. In intensity equals to power over area, power per unit area. And we have a relationship. This is not really a formula, it's just a relationship that you should know. It's good to know. Intensity is directly proportional to amplitude squared. So this will come in handy when they give you the value of, let's say, initial intensity and they ask you to find a new intensity value. For instance, let's say they give you, okay, initial intensity is maybe 6. Then the amplitude initially probably is 4. Now they ask you to find what is the new intensity when your amplitude is 9. So how would you do it? So since they are directly proportional relationship, you can do like this. I new over I old equals to, because it's directly proportional, right? It's A new over A old. So your new is what you're going to find. Sub in your old one as 6. Square, square. Remember your square. Remember your square, I tell you. Remember your square. If you think you'll forget, write this down. Write this down. So when you write, you're going to follow this. Remember your square. 4 square, sorry. New is 9. Square, 4 square. Do normal maths. I new, you get your value. Yeah. This is directly proportional. I usually do this way. If let's say you want to apply this to an inversely proportional relationship, so I'm just going to simply give you a random. Let's say M is inversely proportional to 1 over G. Not inversely proportional to 1 over G. It's basically inversely proportional to G. Right? So now you want to find the relationship. Let's say they say M. This is not an actual relationship. I'm just giving you a random relationship. M is 7 when your G is 9. Ask you to find what is M, your new value of M, when your G is 10. For example, so since this is an inversely proportional relationship, n is inversely proportional to g, how would you write it? M new over m old equals to g old over g new, because it's inversely proportional, so it must be inversely proportional. Sub in your value, you'll get your answer. Yeah. Okay. Alright. Simple, right? Okay. Then next one we have malus. Malus. Good question. I know you might be thinking how to pronounce that. It doesn't matter because physics is not a speaking test. As long as you know how the formula works, you are good to go. So malus, never mind. Whatever is it. Okay, I'm just going to say Malus law. Where I have I equals to I naught cos square theta. I have stated here what is your I. I is the intensity of wave after passing the analyzer. That means this is your analyzer here. I've given you a picture for your reference. So after passing through this analyzer, that is the intensity of your transmitted light. That is your I. I naught is the intensity of polarized light on analyzer. That means before going through the analyzer, which is somewhere here. Before the analyzer or after the polarizer. That means after the polarizer you can call it, or you want to say before the analyzer. Yeah, anything. But yeah, before pass through the analyzer lah, in simple words. And theta is angle between the plane polarized wave and axis of analyzer, which is this. Okay, let me figure it. Here they use phi. So same thing. You can say theta also. No problem. As long you sub in the right value, you're good to go. Okay. Okay, let me make it smaller a bit. So this is Malus's law. I hope I'm pronouncing correct, but yeah, still it doesn't matter, right? Next one, Doppler effect. Finally, something extra given in exam. Doppler effect. Thank God. This is given in exam. This is given in your formula sheet. So what is FO? FO is the observed frequency. F subscript S is the source frequency. V is wave velocity. V subscript S is the velocity of the source relative to the observer. The wave velocity is usually 240 meters per second. And as far as I remember from the last time I said for my paper, which is last year 2024, winter 2024 was my last paper, they will give you your wave velocity in the question, usually. But if CIA decided to surprise y'all, just keep this in mind, 240 meters per second. And next one, the plus minus depends on whether the source is moving towards or away from the observer. What do I mean by plus minus? This one. So you use plus if the source is moving away from the observer. You use minus if the source is moving towards the observer. Okay. Yeah, so make sure you know when to use it. Alright. Oh, so I just thought of something. Remember, I think this is actually part of waves. I mean, okay, we are in waves. Electromagnetic radiation spectrum. Basically, electromagnetic spectrum. Remember your spectrum. Where is visible light? I know this is not part of a formula, but something that you have to know. What frequency is your visible light? Which one has the highest frequency? Which one has the lowest frequency? Gamma ray, X-ray. Sometimes they'll ask you. They'll give you a frequency range and ask you, what type of radiation do you think is? What type of electromagnetic spectrum? Think where does this fall in? So it's good to know. Yeah. I just suddenly thought in my mind. Yeah. Okay. Then we have this one, constructive interference and destructive interference, where we need to know our path difference. And the formula for constructive is n lambda, and for destructive is n for half the wavelength. So I have a small picture here on my left, not your left. Actually, yeah, same, both of our lefts. Yeah. So this is a simple one I'm going to do to show you the path difference. So let's talk about P2 first. So P2 we have wave coming from S2 and a wave coming from S1. So S2 is 1, 2, 3, 4, 5, 6. 6 lambda. S1 is, we have 1, 2, 3, 4, 5, 6, 7. 7 lambda. So our path difference is 7 lambda minus 6 lambda, which is lambda. Basically, it's ideally 1 lambda. Whereas for P1 from S2, it's 1, 2, 3, 4, 5, 6, 6.5. 6.5 lambda from S1, 1, 2, 3, 4, 5, 6. So 6.5 minus 6 is 0.5 lambda. So path difference for constructive interference is usually a whole number, n lambda, where your n equals to 0, 1, 2, 3, 4, 5, 6, 7, 8, so on. For destructive interference, it's the relationship is n lambda over 2, where your n is actually an odd number, 1, 3, 5, 7. Yeah. So this is for constructive interference and destructive interference that I've shown you a simple demonstration here. Okay, right. Now, chapter 8, superpositions. Formula you need to know, this is Young double slit experiment. And I'm so sorry, honey, this is not given in exam. It's lambda equals to ax over d. But I think, yeah, like I said, if you do a lot of practices, all of these formulas is going to stick in your head after some time. Yeah. For double slit interference using light, yes, lambda is your wavelength. A is distance between the center of the slits. Fringe X is the fringe width, distance between successive your bright fringes. D is distance between the slits and the screen. Okay, for example, this is your slit. Okay, maybe it's two. Yeah, this is your slit. This thing is A. This is your big screen. Okay, that is screen, very wavy screen. Let's put this. This thing is D. And let's say this is bright. This is bright. This whole thing is your X. So bright to bright or dark to dark is your fringe width. Okay, that is your Young double slit formula. Then we have diffraction grating. D sine theta equals to n lambda. So I've stated down here what is each of the letters mean. So D is spacing between adjacent slits. Theta is angular separation from center to the order of maxima. So either from here to here, if they say they want second order of maxima, is from center to up there. N is order of maxima, n can be 0, 1, 2, 3, so on and so forth. And lambda is wavelength of light source. So I have a picture here for you to look at. So D can be calculated from n using the equation where n is the number of lines per millimeter. So sometimes they might give you in exam, instead of D, they give you n. So they say, oh, there is 100 lines per millimeter in this diffraction grating. So how you want to find your slit separation? Basically, how you want to find your D, the spacing between your slits. If they give you n as lines per millimeter, for example, 100 lines per millimeter, or it can be per meter, doesn't matter. For you to find your D, take 1 over 100 because D is in meter. Sorry, in case it's now in this case it's millimeter, right? So just take 1 over 100 to get your D in millimeter. But of course, remember to convert to meter to your SI unit. Yeah. If they give you n, just 1 over n, you will get your D. Okay. And it's not necessarily millimeter or meter. Sometimes they can give you nanometer also. Any way of meter they can give you. Because, there's always a lot of ways. Then the maximum angle of diffraction with which maxima can be seen when the beam is at right angles to diffraction grating. Of course, maximum is right angle because this is the max you can go. So we want to find what is the highest order of maxima. Since this is the maximum, which is 90 degrees, your sine theta becomes sine 90, which is 1. So D equals to n over lambda. So you want to find the highest order, sub in your value to find your n. So that is what is shown here. Yeah. And next thing to take note of, since n is an integer number of maxima, if the value obtained is decimal, make sure you round it down. For example, if n is 3.7, round it up to 3. 3 is the highest order visible. Okay. Perfect. Superposition, finish. Formulas you need to know. Moving on, electricity. Everyone's favorite chapter, right? Electricity. But electricity is a bit nice. This is given in your formula sheet. I know, right? It's given. Okay, but let's look at the few ones after that it's not given. Q equals to IT. Q is your charge, I is current, T is time in seconds. Voltage, or better way to say is potential difference, equals to work done per unit charge. Ohm's law is V equals to IR. Power equals to VI, or just by using this mix and match, you can write power equals to I square over R, V square over R. So which of these three to use depending on the information given in the question itself. Sometimes you can use more than one, but just choose the best one. Then we have resistance. Resistance formula, we have resistivity times the length over the area. Last one, for current carrying conductor, where I is current equals to area times number density of charge carriers, velocity, and Q is your charge. Elementary charge. If I'm not mistaken, okay, actually it's not that I'm not mistaken, I don't remember what's a charge. But yeah, it's given in your formula sheet in front, it's in data, so don't have to remember. So I don't memorize the charge, or if it's given in exam, right, I would not put it in my brain to waste up my gigabyte. I'll use that gigabyte for something else. So it's given in exam actually. Yeah, this Q is given in exam. And this V, you can use to find your drift velocity also. Yep. Basically the V comes from the drift velocity part. Okay. And this is given. Yay, it's given. The funny thing is, right, usually the one is given is the one that you've already memorized. It's okay, I feel you. I've gone through that before. Next one, 10 DC circuits. DC circuits, these two, I think you have seen it before, like IG, CSU, SPM. Resistance, you want to find the total. Take R1 plus R2 if it's in series. If it's in parallel, of course, you want to wait. And remember, to find your R total, after that, don't forget to inverse the entire thing. Don't forget. Remember, don't forget. That's why, doing calculation in physics, don't do it in the intention to do it fast. Do it with clarity. Clarity and focus is very important, because to not mess up the small mistakes, minor, significant figure, all the small things, you don't want to lose your marks for that. Losing marks because you don't know how to do the question, it's okay, because you don't know everything. There are times, there are questions that you're not able to do. It's okay. It's beyond your capability. It's okay. Never mind. The thing is, you tried your best. But don't lose marks for the question that you know, and because of your careless mistake, you lose it. Don't do that. Okay, so next one is your EMF and internal resistance, which is... okay. E is your EMF equals to potential difference or voltage plus IR. I is current, R is your internal resistance. The other way you can write it also is IR plus R. It's just that when you open this, you get IR, so you should away put as potential difference. Up to you, whichever way you prefer. Okay. And last chapter. This chapter is actually no formula at all. It's just this thing. If you are in chemistry or you are taking chemistry, this might be familiar to you. If it's not, you still have to be familiar to it. You don't have a choice. It's physics, and they're gonna ask you, maybe. Nuclear number is the one that's written above. Proton number is the one that's written below. How I remember this, I don't know if you're gonna call me weird again, but it doesn't matter, because I used this way to remember already. Proton, down. On, down. Can you get it? Like, proton is like down. I don't know how. It just works with me. And it has worked ever since SPM. Or IG. SPM. Why did I say or IG? Sorry. SPM. Ever since that time, I was proton is down. Until A-levels, I use it. For some reason, it worked for me. But if you already remember, stick to it, okay? Just, I remember it this way. I just attach this, in case you want to have a look. No formula, something that you have to know. Quarks, leptons, that ask you for sure in exam. For my exam, they did ask. So, yep. This is something 3 marks. So make sure you know. And a note, formulas is highlighted in yellow. I give you an exam, so I've already mentioned that. So give yourself a clap, a pat in the back. We have come to an end. That's it. That is it of the formulas you know. You need to know. So if let's say while I was discussing you suddenly overlook some formulas, don't worry. Calm down. Just go look back a bit. What is it about? Just when you look back, your brain is going to suddenly recall, oh, we have learned this before. So just look back. You don't need to stress yourself too much. You need to relax yourself. Okay, so that's about it for today's video. Thank you for watching. I really hope this helps you a bit for revision, a bit, at least gives you some, memory recall a bit. And no worries, I'll attach the PDF in the description box if you need it. It's for you anyways. So I'll see you in the next one. I'll do one for A2 as well. Don't worry, okay? Bye-bye. Remember to stay hydrated and take care of yourselves.